Now this is a wind turbine. Can you tell us how it works and what are the key differences from typical wind turbines?
Well, with typical wind turbines, they have in the nestles here, they have the gearbox, and this is like what's called the root of the blades, and then they have the gearbox and they have the electric generator.
Right.
And that's where the resistance is in the gearbox. So what we did to go, really specifically to go for low wind regimes, way down to even below 2 miles an hour, we removed the gearbox and we removed the wind generator. We put at the rim, which travels for a given RPM, the rim travels about 9 times faster than the area near the hub. We put the magnets, which you cannot see here, and also the stators all in the mag. So the blades are supported in this fashion.
Okay, so unlike a normal turbine where all the generation happens in the middle, it actually happens on the edges.
Correct.
Okay.
You have the advantage of the speed, and at the rim, you don't need the gearbox, and therefore, with the optimized design of the blades, you can actually get very low wind reaction of this turbine.
So why is low wind so important? Why did you make that kind of essential design?
Because wind blows when it blows, okay? And typically, the Department of Energy classifies wind in 7 categories in the United States, and they don't, there's no such thing as an average wind. So as a result, wind blows 1 mile an hour, about maybe 5 miles an hour, 7% of the time during the year. 12 miles an hour, maybe around 13% of the time, and about 30 miles an hour is about 1 or under 1% of the time. So you have to cover all the ranges of the sort of the wind speed, and the percent of time the wind is at that speed. And these wind turbines should be very responsive to the entire wind regime. That's why most, if not all, wind turbines start at 7 miles an hour. Therefore, they have zero output between 0 and 7 miles an hour, and at 7 miles an hour they just begin to generate 5-10 watts all the way up to their rated power 30 miles per hour. Okay. This one starts all the way from 1 or 2 miles an hour all the way to 35-40 miles an hour.
So if I wanted to have a wind at my home, when would this make sense? I'd still need certain conditions for me to have wind at home, right?
But yes, you see certain conditions. Again, you put on this is rooftop mounted, it's lightweight, and what you really need is some wind. So the higher the better, but you must always have some wind flow. Mm-hmm. But therefore, you must choose a technology that can respond at the lowest wind speed possible.